Welcome back to another one of my learning derivatives episodes. This lesson will be focusing on deriving inverse trig functions using the chain rule and a quick and easy method. Okay, that I know and I can show you. So let's get started with our first example. We have a function y equals arc cos of cos x. Okay, now this is the same as saying cos to the power of -1 and cos x inside. This -1 and the arc at the front is the same thing. These mean the same things, they're just written different ways. So the derivative of the chain rule is you derive the outside, leave the inside the same, and then multiply this by the derivative of the inside. So the derivative of arc cos is -1 over the square root of 1 minus the variable squared. In this case the variable is cos x, so that's what we're going to put in. Okay, then we multiply it by the derivative of the inside. The derivative of cos x is negative sin x. Okay, if we simplify this, we multiply the negative by the negative, we get a positive, so these cancel out, and we'll end up with sin x over the square root of 1 minus cos squared of x. And that is the derivative. Quick, simple, no problem. Now, but just in case you don't understand, the arc cos, the derivative of arc cos of whatever is negative 1 over the square root of 1 minus whatever squared. Okay? Now for our second example, we have y equals arc tan ln of x. Okay, like I said before, it's the same as tan to the power of -1. I'm not going to rewrite that, but now we're going to go straight to finding the derivative. The derivative of the outside, well, arc tan, the derivative is 1 over 1 plus whatever's the variable, ln of x squared. Okay? There's sort of a pattern once you start doing these, that they tend to be 1 over a square root of something, or 1 plus a squared, or if you have the rules in the back of a textbook or you Google them, you'll see there's a sort of a trend. But arc tan is 1 over 1 plus whatever's in the brackets squared. Now we're going to multiply that by the derivative of the inside of the brackets, which is 1 over x, because the derivative of ln of x is 1 over x. And now I'm going to simplify this. Okay, so we're still going to have the 1 on top, because 1 times 1 is 1. And 1 plus ln of x squared multiplied by x, it's going to look like this. Okay, all I did was just multiply the x onto all of this, which is what you're doing. And I just rewrote this a different way. Just like how you have tan x squared, you can have tan squared of x. Ln x of squared is the same as ln squared x. Just written a bit nicer, you could say. Okay, so that's example 2 done. Now for example 3. We have y equals cot -1 tan x plus x. Okie dokie. Cotangent, the derivative. So the derivative of the outside, then multiply it by the derivative of the inside. Cotangent, the inverse, is -1 over 1 plus all of this squared, multiply by the derivative of the inside, which will be derivative of tan x is sec squared x. derivative of x is 1. Okay, so simplify it. We're going to bring this on top, and it's going to look like sec squared x plus 1 all over 1 plus tan x plus x squared. And that's it. That's the derivative. Well, there you go. There's the quick and easy method. I hope you learnt something. I hope you've enjoyed yourself, and have a good day.